Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of x is equal to 2 to the power of 2x. So if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. And if I have something in the form a to the power of m to the power of n, well, we know that a to the power of m times n, this is the same thing as a to the power of n times m, right? These two are the same thing because m and n, these two are interchangeable. So if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m is going to equal a to the power of n to the power of n. And this also means that a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have 2 to the power of 2x. So this is the same thing as 2 to the power of 2 to the power of x. And I can also switch these two. So this is the same thing as 2 to the power of x to the power of 2. Now I'm going to divide both sides by 2 to the power of x. So then these two cancel out, and I'm left with x to the power of x over 2 to the power of x is equal to 2 to the power of x. Now if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So x to the power of x over 2 to the power of x, that's going to be x over 2 to the power of x, which is equal to 2 to the power of x. Now 2, this is the same thing as 4 over 2. So now I have x over 2 to the power of x is equal to 4 over 2 to the power of x. So now I'm going to take the power of 1 over x on both sides. So now I have x over 2 to the power of x to the power of 1 over x is equal to 4 over 2 to the power of x to the power of 1 over x. Now x and 1 over x simply cancel out, so I'm left with x over 2 is equal to, same thing over here, 4 over 2. Now if I multiply both sides by 2, these two cancel out, these two cancel out, and I'm left with x is equal to 4. So this is my answer. Alright, so I have x to the power of 4 minus 25 is equal to 0. So to start, I'm going to rewrite 25 here as 5 to the power of 2. So now I have x to the power of 4 minus 5 to the power of 2 is equal to 0. Now x to the power of 4, this is the same thing as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, that's going to be equal to x to the power of 2 to the power of 2. So I have this minus 5 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x squared and b is equal to 5. So I have x squared plus 5 times x squared minus 5 is equal to 0. So now this is going to give me two equations. I have x squared plus 5 is equal to 0, and I have x squared minus 5 is equal to 0. So for x squared plus 5 is equal to 0, let's first start with x squared minus 5 equals 0. I'm going to first start by adding 5 on both sides. So now these two cancel out, and I am left with x squared is equal to 5. Now I'm going to take the square root on both sides. So I have the square root of x squared is equal to square root of 5. Now the square root of x squared, that's simply equal to x, and the square root of 5, that's going to, sorry, this is actually going to be positive or negative square root of 5. So these are two solutions of x. Now I'm going to go ahead and do x squared plus 5 equals 0. So now to solve this, I'm going to first subtract 5 on both sides. So now these two cancel out, and now I have x squared is equal to negative 5. Now I'm going to take the square root on both sides again. So now I have the square root of x squared is square root of negative 5. Remember, the square root of x squared is simply x is equal to positive or negative square root of negative 5. However, the square root of negative 5, this is the same thing as the square root of 5 times the square root of negative 1. And if you guys already didn't know the square root of negative 1, this is equal to the imaginary number I. So x is equal to positive negative square root of 5I. So these are my 4 solutions to this problem. Alright, so I have square root of 3 to the power of x is equal to 81. Now the square root of 3, this is the same thing as 3 to the power of 1/2. So now I have 3 to the power of 1/2 to the power of x is equal to 81. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 3 to the power of x over 2. So I have 3 to the power of x over 2 is equal to 81. Now, 81, this is going to be the same thing as 3 to the power of 4. Because 3 to the power of 4, that's 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So now I'm going to replace 81 with 3 to the power of 4. So now I have 3 to the power of x over 2 is equal to 3 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, I have 3 to the power of x over 2 is equal to 3 to the power of 4, and notice how both of these bases are the same. Both have 3's for bases, meaning that the exponents, x over 2 and 4, these are equal to each other as well. So I have x over 2 is equal to 4. And now this is just a simple equation to solve. All I have to do is multiply both sides by 2. So then these two cancel out, and I'm left with x is equal to 4 times 2, which is 8. So now to check, I have the square root of 3 to the power of x is equal to 81. So we know that x is equal to 8, so now I have the square root of 3 to the power of 8 is equal to 81. Now remember, the square root of 3, that's the same thing as 3 to the power of 1/2. So now I have 3 to the power of 1/2 to the power of 8 is equal to 81. Now this is the same thing as 3 to the power of 1/2 times 8 is equal to 81. 8 times 1/2 is 4, so I have 3 to the power of 4 is equal to 81, and 3 to the power of 4 is 81. So I have 81 is equal to 81, and this is right, so my solution is right. Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation.